Please.
Okay. Thank you, Mr. Chairman. I'm going to present a brief outline on an experimental study currently in progress in terms of strengthening an intervention technique on historic masonry walls for Scottish monuments, which is part of a wider cooperation between Edinburgh Neighbourhood University and the National Technical University of Athens, supported as well by Historic Environment Scotland, which is the public body that manages and cares for all major monuments in Scotland. So probably you have heard about Scotland being referred to as a nation of stone, starting from the primitive structures of the Neolithic village of Scarabray in Orkney. There was a long way of development till the first castle in the 11th century in Scotland, Castle Sweden. But even if you look in the city centres, you can see that we have an excellent showcase of the use of natural building stones as a construction material. Buildings of the 18th or the 19th century, but modern structures as well as the extension of the National Museum of Scotland use local building stones as a construction material. So this gives you an idea of the quantity of major castles in Scotland. The country is very well known for that. Some of them are immaculately preserved till nowadays and are major tourist attractions. Others are set against some of the most breathtaking sceneries in Britain. And Historic Environment Scotland has the scope to preserve them for the next generations. So castles were introduced, as we said, in the 11th century in Scotland and combined fortification with residence, later on moving in the type of castle-type palaces. So in terms of structural engineering, there are lots of structural typologies that currently ask for our help because they are suffering from deterioration because of age and environmental conditions. So arches, high curtain walls, buttresses, staircases actually need our attention, and Historic Environment Scotland tries to identify and solve problems before it's too late so that we still have these monuments for the next generations. So we identified a topic of common interest between the two universities and Historic Environment Scotland, and we used as a case study Bothwell Castle, which is a castle of the 12th century built near Glasgow, conceived as a five-sided curtain-walled castle dominated by a huge tower here on the southwest side and a big curtain wall to the side. We're going to focus on this curtain wall and the latrine tower that actually is at the worst state currently. So there are issues with deterioration, locally quite severe, because some of the facing structural units are completely missing, and others are quite eroded and powdering currently, which allows water ingress towards the inner part of the monument. And this, together with the acute climate and the freeze-thaw attacks, can really produce major problems on the structural integrity of the castle. So what kind of wall we have in this case? This is what is called rubble masonry. So a multi-leaf wall composed of two external leaves of squared stone, perfectly cut squared stone, and in between we have random material as infill, so randomly cut stone together with mortar. So this is the type of wall that we have in this monument, which is a common typology in Scottish monuments, but one that really has unsatisfactory behavior under both vertical and horizontal loading. And you can see some details here of the south curtain wall and the latrine tower. As we said, part of the thickness of the wall is entirely missing. There are wide cracks longitudinal cracks from almost the bottom to the very top that are quite wide and open, which means that water can come in and create even more problems. You can see the exposure here of the inner infill material in some parts of the wall. So, what do we do about that? The connection between the structural units and the main characteristics of the materials involved are going to determine the extent and the requirements of the retrofitting interventions. So Historic Environment Scotland decided to follow a quite radical approach, which was approved in 2016 and is currently implemented on the monument, by first indenting the stones that are quite badly decayed, and then trying to tie together the multi-leaf wall, so the external leaf to the internal ones, by using a commercial system readily available that comprises a threaded metallic bar, this one here, surrounded by a fabric sleeve, and then a cementitious grout is injected through this plastic tube, making the fabric sleeve to expand and shape itself into the cavity. So these are actually some pictures from the construction site on the latrine tower Bothwell, where you can see the badly decayed stones have been identified, as well as the locations where this anchoring system is going to be introduced. So, after drilling a hole within a mortar joint between the structural units, the anchoring system is placed in the hole, and then the cementitious grout is injected under low pressure within the system. So this was largely based on experience and what we could find in the literature. But Historic Environment Scotland wanted to have some experimental data on this process. So we actually decided to start from determining the pull-out strength of this anchoring system, for which we created a 1 cubic meter wall specimen in our heavy structures lab, using the exact materials that are actually used on site. So this is a red sandstone, a local sandstone called Lohar bricks, together with specifically prepared natural hydraulic lime mortar based on site tests. And we had in our laboratory specialized stonemasons from Historic Environment Scotland, who actually reproduced the exact core filling and stone bolting technique as they do in the monument. So drilling the hole and preparing it to accept the anchoring system, and then, as we said, injecting the cementitious grout that comes together with this commercial system in order to fully bond the anchoring system with the parent material. So this was the experimental configuration that was created for our pull-out testing, a specially designed steel frame that kept our wall specimen in place and supported the testing equipment, hydraulic cylinder connected to a manual pump. Connected to a manual pump that actually controlled the system. Our load cell here, and two LVDTs horizontally mounted on a steel plate connected to the anchor as close as possible to the wall. So what did we find, which was our major interest, because this was just the start of the experimental procedure? We had a pure pull-out failure mode, as we probably expected. So the anchor moved together with its grouted surrounding sleeve as a single volume. The cracks developed centrally, initially just around the anchor, and then expanded towards the sides of the wall, but were restricted it to this area. After removing fully the anchor, we could see that only one small part was missing at the end of the anchor, which was then found in the volume of the wall, as you can see here. I'll come back to the first slide. Firmly attached to the parent material. So the whole behavior of the anchor was described in terms of a load LVDT measurement curve, and we can see that once we reached a load level of 35 kilonewtons and a slip measurement of around 1 millimeter, we couldn't further increase the load, but still the anchor kept its capacity till the LVDT measurements reached around 3 millimeters because of friction and mechanical interlocking within the hole itself. So once the experiment was complete, and we assumed that it was complete when we reached 10 millimeters measurement here, as there was no point of observing any further, we demolished carefully the wall layer by layer to see if there was a crack pattern within the wall. There was none. And actually to find the remaining part of the fabric sleeve in the hole. So we identified some first characteristics for this behavior, which will act as a starting point for the planning of our next experiments, together with the development of a numerical model calibrated to experimental results, which is currently underway. Because the ultimate goal is to do a parametric numerical study to evaluate factors affecting the efficiency of this intervention. Because Historic Environment Scotland would like to have some guidance on how to do this intervention more efficient in terms of structural performance and cost as well, so that is able to produce some design guidelines to give to practitioners. So thank you very much for your attention, and